Assalamu alaikum. In this video I will be showing you how to solve linear system of two equations using the graphical method. Now in my previous video I have shown you how to do that by using the substitution method and the elimination method. Moving on to the third method, which is the graphical method. These are what I like to call the steps of the graphical method. First thing you need to do is you need to make y as the subject of the formula. I don't see it as a necessary step, but for simplicity we're going to do that so we can be able to draw the graph and establish the coordinates. And after we establish the coordinates or the points so that we are able to draw the graph, we will see that if there is any solution between those two equations, you will find an intersection in the graph. And this intersection point, the corresponding x and the y values are your answers to that set of equations or pair of equations. Let's start with this given example. X plus y equals to 5 and x minus y is equal to minus 1. Let's start by making x or y as the subject of the formula, which is by keeping it basically to the left side of the equation and moving any constants or variables such as x itself to the right side. So x is equivalent to 5. If we move the x here, it becomes negative x, and that is the equation that I can use to draw my graph basically. Now let's determine what coordinates. We need to know what are the coordinates so that we are able to draw this graph. So let's say that x is equal to 0. What is the corresponding y value? 5 minus 0, so 5. Y is equal to 5. But if y is equal to 0, what is the corresponding x value? See, this becomes 0. 5 minus x is equal to 0. So we just move the x to the left side to keep it as positive, and you have x is equal to 5. And so my 2 points for this equation are 5, 0 and 0, 5. 5, 0 is on the x-axis where y is equal to 0, while 0, 5 is on the x-axis where x is equal to 0. Now we repeat the same thing with the second equation. This time I would prefer to move the y to the right side since it is in a negative form, and I'd like to keep always the y as in the positive term. So x minus 1 is moved here, it becomes plus 1 equals to y. And same thing, to find the coordinates, just take x equals to 0, which is at the y-axis. 0 plus 1, y is equal to 1. While we take y equals to 0, which is at the y-axis or at the x-axis. This is 0, so if we move this plus 1 to this side, it becomes x is equal to minus 1. And my 2 points or 2 coordinates for this equation are minus 1, 0, and 0, 1. Note that what you can do is you can already substitute the value. For example, you don't need to make y the subject of the formula as I've told you, but what you can do, you can just take x equals to 0 here and take minus y equals to minus 1 in this equation. The negatives cancel out and y is equal to 1, which is the same as this coordinate, to ease up the process and speed it up instead of consuming your time in making y as the subject of the formula. Now we have our points. Let's try to draw them on the graph. Now my first point was, if I go back, it was, if I recall, 0 and minus 1. No, it was 0 and 1. So it was around here. while my second graph was -1 and 0, which is around here. If we're able to draw a straight line, sorry, I'm trying my best. This is my first or second for my second equation, and if we go back to this one, 5 0 and 0 5, if we change the color, 5 0, which is here, while 0 5 is around here, and we draw a straight line. Of course I could have done better. I apologize if the lines are not exactly straight, but this is only an example, and it'd be better if you just use a graphing paper in order to get this accurately, because the problem is with the graphical method, if you do a rough sketch, you might not be able to get the exact answers as in the substitution and the elimination method. Now you can approximately say that there is an intersection at a point close to 2 and 3 here, around here. Wait, let me make it clear with the blue. Here, let's just approximate it as 2, 3. And so x is equal to 2. This is my point of intersection. So this, having those two graphs intersect mean that you have a solution, because if these graphs don't exactly intersect, like let's say if you have the graphs are somewhat parallel to each other, if two graphs or two lines are parallel, they cannot ever intersect, and it means there's no solution. But since we have an intersection point here, it shows that there is a solution for this pair of simultaneous equations, and the x corresponding to this intersection is almost 2 and the y is 3. So my final solution is x equals to 2, y equals to 3. Of course, this is only an approximation because I did not draw the lines perfectly. We can verify it if the answers are quite close to each other by checking over here. So 2, if x is 2 basically, and y is 3, so 2 plus 3 is equal to 5. While here, x is 2, so 2 minus 3 is equal to minus 1. And so we're able to verify that the answers 2 and 3 are indeed the exact solution for this simultaneous equations, and thus we did not make any mistake at all, especially in our graphs. And luckily for us, this is a simple pair of equations, because sometimes you have thirds or you have fractions and decimals. That way you need to be able to use graphing paper instead of just rough sketching. And so this is the final answer to this equation. And what would I like you to do? I would like you to go back to the previous methods in the videos, the substitution method, elimination method. Try solving these equations using those two methods and compare with the graphical method. You will see that all these methods are valuable and are valid for our simultaneous equations. And I would like to thank you for watching this video, and I wish you very good luck, and hope that you put like, subscribe to my channel, and so you'll be able to support me. Thank you very much.